Hey everyone, I am Miss Hu, your physics teacher. In this video lesson, we're going to be learning about prefixes. So first of all, what's a prefix? Now, if you're quite good at the English language, you would know that the term prefix refers to any word that you add to the front of another word that usually changes its meaning. So for example, even pre in itself in English is a prefix of sorts. For example, if you add pre before the word prepare, so pre-prepare means to prepare ahead of time. So that's an example of a prefix in English. So why are we learning this in physics? Because the term prefix in physics has a different meaning, and you do need to know your prefixes. So in physics, a prefix is a letter or a word placed before a unit of measurement to indicate a multiple or fraction of that unit based on powers of 10. So prefixes are used together with units. If this definition doesn't make sense, don't worry, we're going to go through some examples, and once you learn those examples, they're very easy to understand. So let's go through one example you would definitely have come across before in your life. For example, the unit centimeter. So the fundamental unit in this case is meter. What we've done is we've added the term centi to the front of meter, which means that centi is a prefix that we add to the unit of meter. By adding this prefix of centi, we've changed the value of the unit. The term centi has a value of 0.01 meters because, as you should have learned before this, 1 centimeter is 0.01 meter. So instead of saying 0.01 meter, you can say 1 centimeter. It has the same value. Now, if you look at the definition, it does mention here that it's based on powers of 10. It is okay if you wanted to leave the value in decimals, but when it comes to solving mathematical equations, it's easier if you could use the powers of 10. So 0.01 is actually equal to 10 to the power of negative 2. That means 1 centimeter is equal to 10 to the power of negative 2 meters. Now, obviously, we don't always write it in full form. For example, the unit for meters, short form is m. So the short form for centimeter is cm. The C in this case refers to the letter we place in front of the unit, which changes the value. So cm and centimeter, same thing, just that one is in its short form. Now, are there other prefixes you need to know about? Of course there are. So here is a list of some of the common prefixes which you would need to know. There's tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, and femto. Now, actually, the list of prefixes is a lot longer than this, but on this slide, I've only put some of the prefixes that you should know. So this is the prefix in its full form, and this is the short form. Now, take note that the capitalization of the short form does matter. For example, tera is capital T, giga is capital G, mega is capital M. The rest are in small letters. Now, using the correct form, the letter does play an important role, meaning whether you use capital version or the small version, or as some might say, the uppercase or lowercase letters do make an important difference because they do carry different values. For example, you can see that mega is a capital M, whereas milli is a small letter m. If you mix that up, the values become extremely different. On the right-hand side of the table are the values in powers of 10 and the value in decimals. Now, I strongly recommend that you don't memorize the value in decimals. It can get extremely confusing. So you should be memorizing the value of the prefixes in the powers of 10. It'll be a lot easier for you to solve the questions mathematically. So some things to just point out to you in terms of the prefixes. Most of the letters are in smaller cases. The larger values tend to be capitalized just to show how big they are. And most of them are single letters except for deca, which is DA. This is to establish its difference from the value of deci. You also find that all of them use the typical letters from the Roman alphabet, except for micro, which looks very different. This is actually taken from the Greek alphabet. This is the Greek letter mu. So micro is the only one which is not from the same alphabet as the others. If you're wondering why we're using a different letter for micro, it's because the letter M, which micro starts with, is already taken with milli, which also starts with the letter M. Now let's look at the values. You notice that beyond 3, the values of the powers of 10 are in increments of 3. So we start from the base value of power of 0. you will find that as we move up, it goes 1, 2, 3, and after that, it's increments of 3, 6, 9, 12. Whereas if you go the other way to the negative, from negative 1, negative 2, negative 3, then it jumps to negative 6, negative 9, negative 12, and negative 15. So the reason for this is because when the number starts to get very large or very small, we normally write them increments of 3. For example, from 1,000, you go to a million, a billion, and so on. The same principle also applies when we go to a smaller value below 1. So how do we use prefixes? You can use the prefix to virtually any unit. I'm going to move my face over here so that it doesn't block the table. And do take note, of course, this is for the metric system. So you can add the prefix to any unit. So for example, if we have a value like this, 35 TS. So as you can see, this is a capital T, which means that this is for tera, while the small letter s is, of course, for seconds. So this is 35 teraseconds. Now, if you wanted to convert this value to seconds without the prefix, what you would do is you would take away t, which I'm going to just highlight here. This t is equivalent to the value of 10 to the power of 12. So all you do when you want to convert the value is to keep the value of 35 and replace t with the value of 10 to the power of 12. That means 35 TS or 35 teraseconds is equal to 35 times 10 to the power of 12 seconds. Now, of course, you have to always write this back in the correct standard form. That means the value should be written as 3.5 times 10 to the power of 13 seconds. Let's look at some more examples. So if you have a value like this, 0.86 mg, and this is capital M. So capital M is mega, and G, of course, stands for grams. Now, this m, which is mega, has a value of 10 to the power of 6. So to convert this value to the unit of gram without the prefix, you would rewrite the value of 0.86 and just replace m with the value of 10 to the power of 6 like this. Rewrite this in standard form and you would get 8.6 times 10 to the power of 5 grams. What if you have an example like this, 160 DAM? Now remember that DA is the only prefix which has 2 letters instead of 1. So DA is deca, and deca has a value of 10 to the power of 1. How you convert it? Same thing. Carry over the same number, 160, replace DA with the value of 10 to the power of 1, and you get 160 times 10 to the power of 1 meters. In standard form, that will be 1.6 times 10 to the power of 3 meters. Writing the prefix, of course, is not limited only to values that are greater than 1. What if the value goes below 1? So let's look at this one, 5,000 mu k. Yes, I know it looks like UK, but remember, as I mentioned earlier, this is the Greek letter mu. So this Greek letter mu represents micro. Micro has a value of 10 to the power of negative 6. And what does K stand for? This is capital K, which is for Kelvin, which is the SI unit for temperature or absolute temperature. So to convert it, you get 5,000 and the value of micro is 10 to the power of negative 6, giving you 5,000 times 10 to the power of negative 6 Kelvin. Rewriting this into standard form, you would get 5.0 times 10 to the power of negative 3 Kelvin. The units don't always have to be base units only. They can be any SI unit. For example, we can have a value like this, 0.027 NPa, where this small letter n stands for nano, which has a value of 10 to the power of negative 9. So PA, as you should know, stands for Pascal, which is the SI unit for pressure. So to convert this value into Pascal without the prefix, you would copy the original value over of 0.027, replace n, which is nano, with its value of 10 to the power of negative 9, and then we rewrite this into the standard form, which is 2.7 times 10 to the power of negative 11 Pascal. So this is an example of how we use prefixes and how we convert those value of prefixes back to the unit. So for those of you who are wondering, do we really need to know all of these prefixes? Yes, you do, because prefixes is always associated to units and you need to know what these value of the prefixes are. In the examinations, they're not going to be telling you what the values of these prefixes are. You at least need to memorize a short form or recognize them in the questions as well as their associated value in powers of 10. Now the good news is that list I showed you earlier is a lot longer. If you look at this list, you'll find that there are certain prefixes which I have removed because those prefixes are not so commonly used anymore. So if you're taking your IGCSE, SPM, or A levels, these are the more common prefixes that could possibly come out in the questions. So the kind of questions they could ask you with prefixes aren't going to be straightforward. They're not going to ask you to convert the prefix value to its fundamental unit. Instead, what's more common is that they'll give you a calculation question involving any of the equations in any of the topics that you've learned, but they'll just add the prefix to any of the values and you're expected to be able to convert them. So for example, instead of giving you the speed in meters per second, they could give you the speed in millimeters per second. So the more common prefixes you need to know are tera, giga, mega, kilo, deci, centi, milli, micro, nano, and pico. If you'd like to have a copy of this prefix, I'll drop a link to this particular slide in the description below, which you can download for free. Now in this video, I only explained how to convert the values with the prefixes into its basic form without the prefix. If you'd like to know how to convert a value from one prefix to another, I do have a video which explains how to do this, and I've simplified this in a way that's easy to understand. So even if you're not very good at mathematics, using the method that I teach you in this video, you'll find it's very easy to convert. So watch this video. I'll put the link to this video in the description below. So just to show you a snippet of what's inside this video, I show you how to convert from one prefix to another using simplified, mathematically correct methods. And that is all for this video lesson. So if you found this video to be educational and helpful, do click like and leave a comment below letting me know how you have found this video to have helped you. If you would like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. For notes, quizzes, and syllabus updates, visit my website at physicsrocks.com. Do check out videos on other topics in my YouTube channel, which you might find helpful. Of course, subscribe for more free physics lessons from your physics teacher, Miss Hu. Also, for more benefits, do join our YouTube membership program. For more information about the YouTube membership program, visit my YouTube channel at Physics Rocks by Miss Hu. Happy studying!